Why does Earth seem so deliberately placed? Even the slightest orbital deviation, and we might not exist. To give you a vivid sense of this, I'm going to have you drop me off from the spacecraft to experience the most terrifying environments on these solar system moons. Then you'll truly understand how rare a perfect 10-planet like Earth is in the cosmos. Our first stop is Triton, arguably the most promising of the bunch. As Saturn's massive satellite, Triton's extreme temperatures and dense atmosphere will make this an extremely perilous journey for me. It's the only moon in the solar system with a substantial atmosphere. Instantly, a heavy pressure hits me. The atmospheric pressure here is 1.5 times that of Earth. I feel like I'm 15 meters underwater. Everything is a deep, murky yellow. Atmospheric analysis shows it's 95% nitrogen and 5% methane. I must constantly monitor the integrity of my suit's seal. Even the slightest oxygen leak could trigger a catastrophic explosion. I cautiously begin to explore. Look. In the distance, lakes are shimmering. This is the only body in the solar system, other than Earth, confirmed to have stable liquid lakes on its surface. The temperature here is incredibly low, and liquid methane rains down to form these lakes. The detector shows the lake is filled with liquid methane at minus 180 degrees Celsius. I'm collecting samples along the lake's edge when my foot slips. I tumble into the frigid depths. Methane density is only half that of water. I can't float at all. Before I can even struggle, my body sinks uncontrollably, descending so rapidly that not a single ripple is disturbed. I won't drown, because before I even realize I need to breathe, my lungs and my entire body will be completely frozen solid in seconds, transforming into an eternal ice sculpture. If this experience is rated out of 10, I give Triton a 9. My ending was swift and quite unique. I deduct 1 point because I faced a double whammy. 1, freezing, and 2, the potential explosion risk. Since we're still near Saturn, let's take a look at Enceladus Saturn II. The temperature here is even colder than Triton, dropping to minus 201 degrees Celsius. Its diameter is only 504 kilometers, about 10 times smaller than Triton. Consequently, the surface gravity is just 0.113 meters per second squared, nearly 100 times lower than Earth's. Its diminutive size means that any seismic activity caused by the constant tidal stresses from Saturn's immense gravity can be felt everywhere on this moon. These powerful events can rip entire sheets of ice apart and jettison them into space, or trigger powerful ice quakes that could bury and swallow me whole. Beneath the ice sheets that nearly entombed me is a hidden, global ocean. In the South Polar region, the ice shell is about 1.94 kilometers thick. I see gigantic geysers in the distance, erupting through fissures in the crust, constantly spraying ice crystals into space, continuously feeding material to Saturn's spectacular earring. I try to dig through the ice, but the detector gives a fatal warning. These plumes don't just contain ice, they also harbor gases buried deep in the core. Methane, nitrogen, carbon monoxide, and hydrogen cyanide. That's the same poison spies take in thriller movies to avoid interrogation. Scientists believe hydrogen cyanide is one of the chemical bases for creating life. But when sprayed directly into your face, it's a sign of life's termination. A powerful jet of vapor erupts without warning from a fissure right by my feet, hitting my face shield directly. Within a minute, I experience respiratory failure, seizures, and then everything ends. What a shame. I died before I even got a chance to explore the vast ocean beneath the ice. I give Enceladus a 4 this time. The process was a bit messy, and I didn't get to see the moon's most essential feature, the subsurface ocean. A poor experience. Saturn has too many moons. I can't end on every single one, but there is one more we must see: Mimas Saturn E, a real-life Death Star. The massive Herschel impact crater on its surface is 130 kilometers across and 10 kilometers deep. It looks like the gigantic rock from the abyss of Ning. This massive crater, resembling something from a comic convention, is too tempting not to explore. I leap into the enormous pit. The gravity here is extremely low, only 0.044 meters per second squared. So, this will be a long fall, a full 9 minutes. In the endless dark, all I can do is wait for the final impact. Although the initial descent is slow, my speed accelerates to 129 kilometers per hour by the time I crash into the bottom. Waiting 9 minutes for that final splat. That's way too much foreplay. A thumbs down. I give it a 3. Leaving Saturn, our next stop is Phobos, Mars' largest moon. If you thought Mimas was small, Phobos is a miniature world. It's only 22 kilometers in diameter. Its small size naturally results in ridiculously weak gravity, just 0.1% of Earth's. Here, I feel like a single jump could turn me into Superman. Excitedly, I drive the rover across the rugged surface. But the escape velocity here is only 41 kilometers per hour. I accidentally press the accelerator too hard, and there's no coming back. I, along with my rover, drift into the endless void, watching the tiny moon recede further and further into the distance. My end comes in absolute solitude, suffocating after the life support system runs out of oxygen. The irony is that Phobos itself is doomed, just like me. It's spiraling towards Mars at 2 centimeters per year, and in about 50 million years, it will be completely torn apart by the planet's gravity. Overall, this experience was fun. I give Phobos an 8. The high speed and fast and furious action, leading to my eternal exile into space, this ironic and lonely ending, is very cinematic. Not bad. Now, let's head to the coldest place in the solar system, Triton, Neptune, I. It receives 900 times less sunlight than Earth. Any light that does reach it is immediately reflected back into space by its icy surface. My suit's external sensor reads -232 degrees Celsius. The air here is almost entirely nitrogen. But the deadliest fact is that nitrogen's freezing point is -210 degrees Celsius. This means that on Triton, even the air itself will condense into frost on my face. This extreme cold is something no spacesuit can withstand for long. I can feel the heat in my life support system draining away rapidly. My lungs sting from breathing the increasingly cold, recirculated air. My blood feels like it's about to solidify. I hear there are ice volcanoes here, but I won't get a chance to see them. In this environment, death only takes a few minutes. And due to the extreme cold, my body will be numb, so I won't feel any pain. I give Triton a 1 for this experience. There's nothing here but unbelievable cold. It's no fun at all. Dying too quickly leaves no time for the experience. Thumbs down. Let's return to the familiar territory of Jupiter. Each of its celestial bodies is drastically different, so I can experience a series of truly spectacular ways to meet my maker. I'll start with Ganymede, Jupiter 3, the solar system's largest moon. At 5,270 kilometers in diameter, this moon is larger than Mercury. It's not just huge, it also has a metallic iron core, making it the only known moon with its own magnetic field. Due to the continuous interaction between its magnetic field and Jupiter's, this moon features powerful auroras, similar to Earth's. However, this beautiful spectacle hides a death trap. Because Jupiter's magnetic field is so incredibly strong and vast, Ganymede actually orbits inside its magnetosphere. With Ganymede having its own magnetic field, the interaction between the two fields can be devastating. Orbiting near Jupiter places me within its immense and lethal radiation belts, with intensity comparable to an exposed nuclear reactor core. The suit's electronics are fragile. The intense radiation instantly fries my electronic systems. This is followed immediately by the life support system depressurizing. The depressurization is so rapid that the air inside my body violently rushes out of my lungs, forming bubbles in my blood vessels. My blood instantly boils. The most pathetic part is that I only realized after my demise that the auroras here are ultraviolet light, which my naked eyes couldn't even see. I wanted to give this moon a 7, but since I didn't see the aurora, I can only give it a 1. Next stop is Callisto, Jupiter 4. This is the solar system's most ancient shooting range, boasting the most cratered surface. The reason for coming here is that the moon has virtually no geological activity. Unlike many other moons and planets where volcanic eruptions, plate tectonics, or other forces reshape the surface over time, Callisto's crust has remained virtually unchanged for billions of years. It also lacks an atmosphere. This means nothing protects me. A minuscule meteoroid, hurtling in at 50,000 kilometers per hour, hits me like a supersonic bullet. It effortlessly pierces my spacesuit. Depressurization, bodily rupture, and then instant freezing in a -140 degrees Celsius environment. This way of ending is as timeless as the planet itself. The sight isn't pretty. I can only give Callisto a 2 for this experience. But speaking of ugly sights, that would be Io, Jupiter I. As the spacecraft slowly approaches that sulfur yellow volcano-ridden lava-strewn world, it's clear this is a true hellscape. So, I've decided to skip the landing this time. My next target should be an obscure moon, perhaps Charon, Pluto I. This is Pluto's largest moon. But Pluto is small, so all its moons are naturally tiny. This means very weak gravity. The escape velocity here is 2,100 kilometers per hour. I can slam the accelerator without restraint. See. Charon's surface is covered with mountains and canyons. These features indicate past unstable geological activity. Billions of years ago, Charon was geologically active. Internal heat caused its ice shell to fracture, forming massive tectonic rifts and even triggering cryovolcanic eruptions. But that era is long gone. Lacking tidal heating from Pluto, Charon cooled down, turning into a frozen, silent world. But my rover wheels get stuck. There is no violent death here. Only endless waiting. Communication is severed, and rescue is hopeless. My fate is not a swift end, but to be a companion to eternal solitude on this frigid, distant planet until my supplies run out. I give Charon a 6 for this experience. While lacking instant thrills, this prolonged despair has a unique flavor. For the final stop, I finally return to a familiar place, the moon. From here, I can clearly see our blue home. A false sense of security washes over me. I can even see all of you, watching me from Earth. But the danger comes from the most minuscule source. A tiny micrometeorite impact leaves a nearly imperceptible crack on my helmet. The extremely small, sharp, and electrostatically charged dust on the lunar surface enters my respiratory system through the crack. This dust is like countless tiny shards of glass, tearing my lungs from the inside. I start coughing blood, eventually suffocating in my own vital fluid, my eyes still fixed on the distant Earth. I give the moon a 9 for this experience. This ending is full of drama and tragedy, being able to gaze upon home, but unable to return. My journey of tempting fate ends here. Every mission's conclusion proves the same thing. Life is a fragile accident on the cosmic scale. Do we look up at the stars to find the next home, or to better see ourselves? Perhaps the endpoint of exploration is not to find the next perfect 10 Earth, but to learn how to protect the one we are so fortunate to have now.